Hello everyone. So today we are going to see GFGPOD and the problem is K pangram. So here we are given a string and integer K. So we have to return true if string can be changed into a pangram after K most operation, otherwise we have to return false, right? So what is a panagram? First we have to know this. So a panagram is a sentence containing every letter in the English alphabet. So here we are having constraints like it can vary from a string size can vary from 1 to 10 to the power 5, and its k value can vary from 0 to 50. A string may contain duplicate characters, and string contains only lowercase alphabet or spaces, right? All lowercase alphabets should be present in the panagram. So how we can make this possible? So there are two conditions we have to check. The first condition will be, so I'm writing here. So first condition will be if the number of alphabets is less than 26, then we can't make it to panagram. We have to return false for sure. Why? Let's understand. Let's suppose we are having alphabets here and no spaces. We are not considering the spaces as the alphabets. So if we are having alphabets less than 26, then we can't make any changes to make it to 26 letters panagram, right? So in that case, we have to return false for sure. The other condition which will be the deciding factor whether whether we can make a panagram or not is that if the alphabets we can change, those should be of length less than or equal to k. So how we can get that? So let's see this example where a string is containing only a and 26 time a is coming. We need here b to z all the characters inside this to make it as a panagram, right? So we need at most 25 operation to make it as a panagram, and k is here 25. So we can make 25 changes to make it as a panagram. So the condition will be if the zero frequency elements are less than or equal to k, then only we can make it as a panagram, otherwise we can't make it as a panagram. So this is the main intuition behind this problem. So let's code it out. Before coding, let's understand what is the expected time complexity and its expected auxiliary space. So here expected time complexity is big O of n. It means we can run a for loop. The intuition we can think like if expected time complexity is big O of n, then we have to go with one for loop or just traversing in the length of string given, right? And here expected auxiliary space is constant, so here big O of 1. So we can think of, even if we are taking some data structure or working with them, then we have to think of constant extra space, right? So here we are going to take a constant extra space uh, to get the frequency of each character. So here I'm going to take an array of size 26 to take care of the characters coming inside the string. And then we will traverse in the string characters. So string dot to char array. And if the character is not a space, then only we will do some operation, because a sentence can be of letters as well as the spaces. So we will just neglect the spaces and we will work on the alphabets because we have to deal with the alphabets. So here if it's not a space, then we will increase the frequency of this character. And one more thing, that we will count the alphabets. So here we will keep one variable alphabet which is initially 0, and if alphabet is less than 26, it means we can never make it to a pangram. We will just return a false here. Otherwise, we will count all the elements which are having zero frequency, means which are not coming inside the string. So we will take care that with traversing in the array, if I is equal to 0, we will count it. So let's take a variable namely cnt count, and initially it will be 0, and here we will return if cnt is less than or equal to k, it means it will return true, otherwise it will return false, right? So this is the main intuition and the approach for solving this problem. So let's compile and run it. Okay, sorry, here we have to increment it, right? So the given test case got passed. Let try with another test cases as well, right? Let's submit it. Okay, so let's discuss our solutions time complexity and the space complexity. Here we are traversing inside the string characters. So if string length is n, then our time complexity is also big of n, and we are using a constant space array, means it is of length 26, it is fixed and it is not varying upon the length, so we can consider it as a constant space. And yeah, this is the complexity of this problem's solution, and I hope this is helpful to you to understand the problem and the approach and the complexity. If you find this helpful, do like, share and comment. Thank you.